Hello class, today we're going to be looking at the start of the rock cycle. So this is going to be lesson number 3 if we count the first lesson just being introduced into the course, or introduction to the course. So we're going to look at the rock cycle, and we're going to start by first looking at how we can kind of connect it to plate tectonics and looking at the 3 basic types of rocks in this rock cycle. I don't want to go over too much information in one day. So we'll keep it kind of basic, and then we'll kind of build on these ideas. I think I want to have 3 to 4 lessons on the rock cycle. I don't want to go too far into it, but I want to cover some of the interesting things. So this might be a lot of review for people from Science 9 or Science 10 or even Science 8. So bear with me through this. So we'll start looking at the oceanic plates. So oceanic plates have their own sort of rock cycle that we can think about. So we talked about plates being recycled, and this kind of lines up with the rock cycle. So when the oceanic plate gets pushed down into the mesosphere, when it collides with any other type of plates, it melts. So this is like the beginning of the rock cycle, this melting of the rock. Um, so when we melt the rock, we can think of it as destroying the rock. The rock is going to form something new. So the old rock gets destroyed, and we get this. Well, it's not a new rock yet, but it's this melted rock that's not really new or old, if that makes any sense. So when this oceanic plate has new rock forming on the other side, so when it gets pushed down, it's moving, and the other side of the plate, we get new rock forming. This new rock forming, it's this melted rock from the mesosphere. It forms a solid, and it adds on to this plate. So this is what we call new rock. So when we age the rock, it is aged from the last time it was melted or changed. So sometimes it doesn't have to be completely melted to be considered a new rock. It has to go through some sort of chemical change. This chemical change can be the atoms rearrange a little bit. Depends on how much pressure, how much heat, or if the rock gets worn down and forms into like a new rock. So that is the sort of the mini rock cycle that's on the oceanic plates. Now, we're not going to focus on that too much. It just kind of puts sort of a rock cycle in perspective. You get old rock, breaks down, gets destroyed, it melts down, and then you get new rock forming, and the age of that rock changes. So on continental plates, we get a more defined rock cycle. And there's different types of rocks we can focus on here. But this is the rock cycle that we're going to spend our time on. So before we get right into this rock cycle, one important idea that I want to focus on in this section is that energy and matter is never destroyed or created. The total amount of energy or matter in the universe, everything that we have, is constant. It stays the same. It changes all the time. It's constantly changing, but there's never more or less energy and matter. And I say energy and matter because essentially they're the same thing. When you destroy matter, you get energy through the famous E equals mc squared equation. But we can get more into that later if you have any questions about that. But essentially, energy and matter is always constant. So into the rock cycle. I've drawn you a little diagram of the rock cycle here with the 3 main types of rocks. So we have igneous rock, sedimentary rock, and metamorphic rock. So these are the 3 main types of rocks that we're going to focus on in the rock cycle. And each of these groups of rocks or types of rocks has subsections of rocks where it's like granite, or this is limestone, or this is going to be marble. So we can name rocks separately, but these are kind of the groups they would fall into. So here we can see that these types of rocks can move into other types of rocks. And we'll get more into how they move and what happens to change into these rocks next lesson. But for now, to answer one of the questions I asked, so sedimentary rock can become metamorphic, and metamorphic can become sedimentary rock. Igneous rock can become sedimentary, but sedimentary rock cannot just become igneous rock unless it goes and becomes metamorphic first and then goes to igneous. Again, we'll get more into detail how these transformations happen next lesson. So This is a very simplified rock cycle, just to kind of get it out there. Today's lesson, what we're going to focus on is more on the 3 different types of rocks. I'm just going to make this one page for you. So let's first look at sedimentary rock. An example of sedimentary rock would be sandstone. Limestone's also a good example. So if you want to pause the video, if you're curious what it looks like, you can look up an image of sandstone or limestone. So let's start by breaking down the word sedimentary. So we can see that there's sedimentary has a component where it's just sediment. So sediment is the basis of sedimentary rock, where sediment is just small bits of rock, sand, dirt that fall to the bottom of a body of water. And this is what we call sediment. So if you're ever in a lake and you like your feet kind of sinks into the sand and it's just like gross and gross, that is sediment and it's forming the lake. So what is sedimentary rock? How can we use sediment, the word sediments, to help us with sedimentary rock? So as more and more sediments form on the bottom of a body of water, they build up and there's more pressure on the rock below. So they just compress it and keep compressing it. And what this compression does is it compacts the sediments along with the water that's trapped in there, and it forms a new rock that we call sedimentary rock. So all this pressure, along with a little bit of water, creates almost like a concrete. Some people even call it a concretion, where the individual bits of particles of rock, sand, and dirt become one single rock. So that new rock is what we call sedimentary rock. So it's formed from sediments. How to identify sedimentary rock? So sedimentary rock are maybe the easiest to identify because generally they'll have layers on them. So very defined layers. This is due to different sediments forming or different sediments falling and then getting compressed through different seasons or even different years. So if we're looking at old sedimentary rock, we can see even decades or time periods where there should be different types of rock or different types of compounds in the sedimentary rock. So we want to look for those layers. Sedimentary rock also tends to be more brittle or soft than other rocks. One more thing I'll say about sedimentary rocks. Generally, they'll contain some biological matter. So different bacteria or very small animals get trapped in these rocks. So they're very useful for looking back in time and seeing what the world might have looked like millions of years ago. So moving on to igneous rock, an example of igneous rock would be like granite. So breaking down the word igneous, this one I enjoy, comes from a Latin word ignis, which means fire. So igneous rock is really built in or formed from fire. We can see this when we look at what is igneous rock. So igneous rock forms when magma cools. So all the melted rock that's in the mesosphere breaks through the crust through a volcano or magma plumes and spills onto the surface where it cools. This can happen in the bottom of the ocean. This can also happen on land. And this is going to form igneous rock. And as the melted rock cools, we get small crystals forming into it. So if you ever look at a rock and it's kind of like shiny, those would be like crystals forming. How to identify igneous rock? Small crystals that I just mentioned, but these crystals won't align with each other. So they'll be kind of random directions. The light will shine off them randomly. They're not going to be aligned. Igneous rock can also be holy. Depends on how it cools, but there can be porous, a lot of holes in it as well. And it's going to be middle on the brittle scale generally. So it's going to be harder than sandstone, or it's harder than sedimentary rock, but not as hard as the next type of rock, metamorphic rock. So an example of metamorphic rock would be marble. So breaking down the word metamorphic, this one's a bit tougher, but meta comes from Greek origin, for like change in form, which aligns with how metamorphic rock forms. So metamorphic rock forms when igneous rock or sedimentary rock, so any other type of rock, gets put under enough heat and pressure. So heat, you'll melt it down, but that pressure is key as well, because that pressure is going to form it into a solid rock. And what this heat and pressure does is the atoms in the rock, they change how they align with each other. So it changes the structure of the atoms in the rock. And this can have drastic forms in the change of the appearance of the rock, changing color, changing how solid the rock is, and it forms an entirely new rock. So when we age it, we'd age it back to when this process happened, where the heat and the pressure changed the rock. So how to identify metamorphic rock? So because the atoms will align, because of this immense amount of heat and pressure, metamorphic rock will have rows or bands of crystals that are facing the same way. So unlike igneous rock, where the crystals point all different ways, metamorphic rock, you can see like bands of crystals that face the same way. So you can kind of see that with marble, and you look at marble, you can see it shines in a very it shines in the same direction, where igneous rock shines kind of everywhere. Metamorphic rock also tends to be the hardest rock you'll find. Sometimes it's not the case. There's different types of rock that may be more soft or more brittle, but with metamorphic rock, generally, they're the hardest rocks. And that's the end of lesson number 3, not lesson number 1, lesson number 3. Yeah, so this will come out on Wednesday, so I'll see you all tomorrow if you have any questions on the Thursday video call. And there's also questions posted on Google Classroom. Have a great rest of the day.